Whenever you've got a question like this, I always find it really useful to draw a diagram. So it's not referring to your parent over here, it's just draw a diagram. Diagrams don't have to be great, they just have to be good enough to see what's going on. So what I've got in this particular case is my point A is at minus 110, my point B is at 5, 1. And I'm interested in that straight line. The reason I'm interested in that particular straight line there is because this question asks me to find the coordinates of the point, and what it's really referring to there is a simultaneous equation. So it wants you to solve a pair of simultaneous equations, and we know that there are lots of different ways of doing that, but before you can solve it, you've got to find the equation of the line AB. So first thing I need to know if I want the equation of a line is its gradient and a point it passes through. If I know the intercept, that makes life really easy, but in this particular case I don't. So what I'm going to do is I'm going to drop in a vertical and a horizontal, and we know that this point is minus 110. We know this point here is at 5, 1. So if I'm going from minus 1 across to 5, then obviously I'm going across 6. And if I'm coming from 10 down to 1, I'm coming down 9. So my gradient of the line AB is going to be minus 9 over 6, which, because I like things to be easy, I'm going to change to minus 3 over 2. And later on in this question, you'll see why that becomes really quite useful. So my gradient in this particular case is minus 3 over 2. I need to use a point, and I'm going to use the point 5, 1. So I'm going to choose my point x1, y1, and I'll explain why I'm calling them x1, y1 in just a second, as the point 5, 1. Now, there are a couple of different ways of doing the equation of a straight line. One is to use the traditional y equals mx plus c. So therefore what I can do is I can actually put in the gradient. I can put in my point x equals 5, y equals 1. I can work out c, and then I can work out the gradient, and then I write down my equation. Another way of doing it, which is quite useful, because it gives you this equation of the straight line in its simplest form or in a better form, is to use a version that we've known for quite a while, but not necessarily in that format. We know that the gradient of any line is always the change in its y values. So if xy is 1 point and x1, y1 is another, over the change in its x values. If I rearrange that by multiplying both sides by the bottom bracket, the denominator x minus x1, I will end up with y minus y1 is equal to m bracket x minus x1. And that's a good version to use, and this is why I called this point here x1, y1. So if I plug in my numbers, y minus 1 is equal to minus 3 over 2 x minus 5. And I don't like the 2 on the bottom, so I'm going to multiply through by it. So 2y minus 2, and at the same time I'm going to expand the bracket, minus 3x, taking a little bit of care not to make a stupid error with the sign, because that's one of the most common mistakes. And I'm going to choose to write that one as 3x plus 2y equals 17. I know that I can write it in a variety of different forms, but the reason I've chosen to do it that way is that it links in with what I've got up here, which is my other straight line. I said at the beginning of this that we'd have to solve simultaneously. You can solve by rearranging and substituting. You can solve by making things the same. So I'm going to choose to write that one as 2x minus 3y is equal to minus 6. And that's my second equation that I'm going to use. So I now need to solve those two things simultaneously. And we know that with any equation, we can multiply it through by a number that we choose. And then we can add or subtract equations. And the idea is to eliminate one of the unknowns. Now, in this particular case, because I've got 3x plus 2y equals 17 and 2x minus 3y equals minus 6. Clearly what I need to do, and in this particular case it would be easiest to get rid of the y's because I've got the plus and minus going on there, so all I need to do is add. And even as a mathematician, addition's easier than subtraction because I make less mistakes, hopefully. So I'm going to multiply this equation through by 3, giving me 9x plus 6y is equal to 51. And this equation through by 2, which will give me 4x minus 6y equals minus 12. And I'm simply going to add those two equations together. So this would give me 13x. My 6y's eliminate one another because they're opposite signs. And 51 take away 12 is 39. Which gives me that x is equal to 3. So I now know that x equals 3. I could do with finding out what y is. So if x equals 3, then I'm going to choose to use this version of my straight line again. So if x equals 3, I've got 3 times 3 plus 2y is equal to 17. And I'd be fairly confident that somebody who'd written that could tell me straight off that y is equal to 4, because clearly I've got 9 plus something gives me 17, and that something has got to be 8, and 2 lots of 4 make 8, so y equals 4. Now, one point you've got to be aware of, it does ask me in the question to find the coordinates, so therefore I need to state somewhere that C is the point 3, 4. At that point, I've done this first part of the question, and I'm going to move on to the next part. So I need to determine the ratio in which the line L divides the line AB. Well, we know that the line L, because we've just done it, meets AB at the point 3, 4. That's my point C. We know that AE is the point minus 110, and we know B is the point 5, 1. If I want the ratio, what I'm looking for is the length from A to C. It helps to put the B in there as well. And then from C to B. And the easiest way for me to do that, this is only worth 2 marks. I don't want to have to do a lot of work for 2 marks. Mathematicians don't like doing much work anyway. So again, the thing for me to do is to use my similar triangles. What I've got here, and I apologize for my lack of skills in artistry, is a couple of similar triangles. I know they've got to be similar because the angles that they form have got to be exactly the same. Even with my rubbish diagrams, you can tell that those two angles that I've marked in are going to be exactly the same. These two triangles are going to be similar, therefore one will be a multiple of the other. So if I look at this, if I'm coming from minus 1 across to 3, I'm just going to change colour so it's a bit more obvious. So if I'm going from minus 1 across to 3, clearly I'm going 4 across. If I'm going from 10 down to 6, I'm coming down to 4. He says, fool. Why is that not writing? Come on, behave. It stopped. It doesn't want to write now. Anyway, it doesn't like it because there's something over there. I think minus 6. I apologize for the fact it has to be over there. And again, if I do the same on this one, I'll change to Ooh, let's go yellow. If I'm going from 3 across to 5, it's coming across 2. Doesn't show too well, but it works. And then if I'm going from 4 down to 1, I'm coming down 3. So if you look at these two triangles, and because I'm coming down, I'm going to put a minus in there. If you look at these two triangles, it's pretty obvious that the triangle that has a hypotenuse of A to C is twice as big as the triangle that runs from C to B. Well, it has a hypotenuse. So therefore my answer in this particular case is quite simply 2 to 1. Okay, I don't need to put the words in there as long as I've got the diagram that supports it, and if my diagram's annotated up properly, it's fairly obvious. But if I was actually doing this for an exam purpose, I would be tempted to say that the ratio of the triangles, because they're similar triangles, something like that. If I then look at part C, I'm now looking at the line L, and I want to know where it crosses the x-axis. So I need to know my line L. My line L was 2x minus 3y is equal to 6. And so this is part C of my question. It's only worth 1 mark. I don't do hard work for 1 mark. Certainly not. I can see straight away, and this is the advantage of being old like I am, I can see straight away that what I'm interested in here is where it hits the axis. We know that it's coming this sort of way. We know that where it's coming from, but we could do with working this out. Now the x-axis, of course, is the line y equals 0. So all I've got to do in this particular case is I let y equal 0, and we all know that 3 times 0 is 0, so therefore 2x is equal to, and of course that's a minus 6, 2x equals minus 6, because remember I changed that on the first slide, x is equal to minus 3. So therefore my point D, and again, if you don't put the coordinates, you're not going to get the marks. All right. Remember, examiners are there to try and give you marks, not to take marks away from you. The other thing that I know in this particular case is I do actually know the gradient, and that will come on in the next question. So there's my answer. D is minus 3, 0, and my diagram didn't help me that much this time, but it certainly gives me an idea of what's going on. I'm going to move on to the last part of the question now. And this part here, 6 marks, I've got to do a bit more work for it. I'm required to show that the line L is perpendicular to AB. So I've got my 2 lines. My AB line runs like that. I've got a point over here, which is D, and I know it's minus 3, 0. But because it's a root, I'm just going to put it down as a minus 3. If I want to put my line L in, I really need to know another point on it, so I need its gradient. So what we had was 2x plus 3y plus 6 equals 0. So if I rearrange that, silly boy, minus 3y. Did think for a minute I was going to do something silly there. We all make mistakes. So 2x minus 3y plus 6 equals 0. So therefore, if I rearrange that, I'll get that 2x plus 6 is equal to 3y. And therefore, that will give me that y is equal to 2/3 of x plus 2. So my intercept is at 2. And my second straight line goes a bit like this. not a particularly good diagram, because what I'm looking to show is that this is a right angle, and that doesn't look much like a right angle, but it'll work. It's really hard to draw straight lines on these things. But anyway, I now know where I'm going. This idea of perpendicularity, we've been told that what I'm looking for there, if I want to prove it, is that my first gradient, and it doesn't matter which one it is because the operation is commutative, it multiplies together, it doesn't make any order, that if I multiply the two gradients together, I'm looking to get -1. Now, that's fine, but it does require us to know why on earth that's the case. And it helps us if we understand why is that the case, because we're not then remembering just things that somebody's told us is true. So if I actually think of a line, and I put a triangle on that line, and I say, right, this side here is A, and that side there's B. If I now rotate that line, then it doesn't matter where I rotate it around. Okay, so I'm going to choose to rotate it around this point, but through 90 degrees. So what will happen now is that my triangle, okay, will look a little bit like this. A, and that's B. But I can see that this is going to be coming down. So my first gradient, M1, is the vertical change over the horizontal change, and because that one is going from left to right and up, they're all positive. My second one, and remember that I said that I rotated that through 90 degrees, my second one is going to be vertical change over horizontal change, but this time the vertical change is going down, horizontal change is still going from left to right, and in which case I get M1 times M2 is going to be B over A times minus A over B, and we can see that everything very nicely cancels, giving us -1. There are different ways of showing that, but that's not a bad way of doing it. Way back beyond, right on the first thing, I said that my line AB had got a gradient of -3/2, and that's what I reduced it to. It started off as -9/6. My gradient of L is 2/3, and it doesn't take much to show that -3/2 times 2/3 is equal to -1. So therefore, these two lines are perpendicular. Now, I now need to find the area of the triangle ACD, and I know that I've got a right angle in it. So my point A and is at -110. My point C, so I've got A at -110. My point C, which appeared and then disappeared, was at 3, 4. And my point D, rubbish diagram, you can tell why I was not allowed to do art in school, -3, 0 is there. And I have got, because I've just worked it out, a right angle there. So what I need to know in this particular case, because I know that the area is half the base times the height, I need to know the length of this side here and this side here. And again, because they're slopey lines, put in my triangles. Well, this one I've actually already had. Okay, I know from my work already that this side here is 4 and that side there is -6, but because I want to use Pythagoras, okay, so if I'm looking at the length of AC, all I need to do is square those, add them together and take the square root. So, and I'm sure Pythagoras never meant it to be written as a squared equals b squared plus c squared. I'm sure he meant it to be square, add or subtract and square root, but that's another matter. So I'm going to do 4 squared plus minus 6 squared. So I'm going to get 16 plus 36. So that's AC squared, isn't it? Remember, it's important to remember that. So AC is going to be the square root of 52. But, and it's very, very common in these questions, it's worth noting there that root 52, look for a square number that goes into it, it is 4 times 13. So therefore, this is 2 root 13. If I then look at my other triangle, and this really is not to scale, which is fine. It's just as well, isn't it? Okay, this side here is 6. This side here is 4, because I'm going from 4 down to 0. And it's going to be obviously the same length. So I've got that CD is also 2 root 13. And I know that my area of the triangle ACD is half the base times the height, so it's going to be 1/2 multiplied by 2 root 13 all squared. Well, if you think about it, I've got AC is equal to root 52, so therefore CD is equal to root 52, and root 52 times root 52 is 52, and 1/2 of 52 is 26. And because I don't know what the units are, 26 units squared, end of question, end of piece of work.